Okay, so let's get started. Sorry for the delay here. Well, too many gadgets today and too few adapters. But anyways, so let's get going. So today we have two lectures, and this will be laying the framework for everything we're going to talk about the rest in the course. So this material, please pay extra attention to this, otherwise things later on will be harder to understand. Okay. So today we will talk about protocol stacks and ways to think about these. And in the first lecture we will talk a little bit about something called the OSI model. So maybe you heard of it before, but anyways, that's what we're going to do. And then talk a little bit about protocol services and layering. Okay, so before we start, a few announcements. So project groups will be signed this evening. So if you haven't received an email about this, that means that somehow you didn't get a group, or we have the wrong email to you, or whatever. So if you haven't received an email about your group this evening, or say tomorrow morning, then you need to take action, because otherwise maybe we don't know you exist or whatever, right? So then just send Shoaib an email and he will take care of it. You find his email in the course PM. Yeah. And I hope most of you have managed to register now. If you don't, you need also to let Shoaib know so you can get a project group. Okay, so let's get started. Networks. So we think of networks as you know, these clouds, and we have some applications running using the network. So what is the network? Well, the network consists of things, computers, which are on the, or some type of device which is on the edge of the network. And this could be an edge device, for instance, or your laptop or whatever. And then there are things in the middle, which are some type of network nodes, which are not necessarily which are not running user software. And these could be then routers, you know, switches like this. And then there are links between these network nodes. It could be cables like this. This is a regular Ethernet cable, or it could be radio links, fiber optical channels, wireless, whatever, infrared. There are all kinds of different types of links here. So a network consists then of many different things. Basically links, which connects nodes, and nodes comes in two sorts, the interior nodes and the external nodes, or not the external, but the edge nodes, those who are on the edge of the network. Okay, and we have a special word for those devices which are on the edge of the networks, and these are called hosts. Okay, and inside we have a special word, and it's also called routers. As you probably know, these words are not unique, so their routers comes in many different shapes and forms, and there are also things here which are not really routers inside, but we'll talk more about that later on. And hosts here comes in many different shapes and forms. It could be like one of these, it could be a computer, iPad, or a stationary computer, or whatever is using the network, which is running software, application software. Okay, so names here. And again, why are names important? Names are important because if you want to communicate efficiently with somebody who deals with networks, you need to know the terminology. Okay, so words are not unimportant here. So applications or app or user, what are those? Those are software that is using the network. So this is running at the hosts, the edge devices. An example of this could be like Spotify, Skype, or Amazon, or whatever, right? These are user software which is using the network in some way. Okay, the host, it's also known as the end system, or edge node, or source, or sink, or edge device. All of these are basically the same thing. It means something which is attached to the network, which is running the application software. Okay. The special word source means that it somehow is generating information, and sink means it's consuming information. So this is when you want to specify if it's something that is generating information, for instance, a web server, or a sink, which could be something that consumes that. It could be like your TV or whatever, right? Which is running IPTV. It's consuming information. It's not generating so much. Okay, anyways, it's something that runs software in order to support applications. And here, I mean, the devices could be many things: cell phones, laptops, servers, whatever. Then, in the middle, we have routers. There are also switches, hubs, nodes, intermediate systems. All of these have special meanings, but all of them are devices which are inside the network. And their function is to relay messages between incoming and outgoing links, and also to maybe provide, basically to provide connectivity inside the network. So this could be your Wi-Fi access point. I don't know if we have one here. I don't see one. Your ADSL modem, if you have one. The fiber box, which is on your wall. Or it could be something like this, which is in a cabinet somewhere, right? Where you plug in your Ethernet cables, and that's your first point into the network. And then there's an Ethernet cable coming out of this going into the network somewhere. Okay. Links or channels are those things which are connecting devices. So one can think of this, the green cable here, as one link. Or a radio channel could be a link. A fiber optical channel could also be a link. And these are specified, and they have special meanings, all the colors in the cables and so forth. And the connectors have meaning here. All right. Any questions on this? Yeah. Just please interrupt me, right? And if I don't ask for questions, you can ask questions anyways. Okay. Communication networks. As you might imagine, communication networks, or at least the ones that we use today, are immensely complicated things. Very, very complicated machines consisting of many, many interacting pieces, both hardware and software. So, I mean, I think one can rightly say that the internet as we know it is probably the most complicated machine on earth, right? It is just immense. Nobody knows how big it is, and nobody has control over it. Okay, so it consists then of routers, switches, cables, radio channels, whatever, and then protocols that we will talk more about that later on, which is, you know, the rules which guides the operation of this network. So when you have a super complicated problem, what do you do in order to figure out how to operate and how to deploy it and how to manage it? Well, the typical thing we do if we have something which is complicated is we split it up into smaller pieces which are more manageable, and then we can engineer these pieces separately, and then we glue them together to get a complete system. It's like a car, for instance. Nobody designs a car, you know, from scratch. It consists of smaller pieces that you glue together. Some people do the engine, some people do the drivetrain, some people do the tires, some people do the windshields and so forth, right? And then you put that together. So the classical approach to deal with complex system is this divide and conquer idea, that you split up the problem into, you split up the overall problem into sub-problems, you solve each sub-problem, and then you glue the sub-problem solutions together to form a complete solution, right? So this is a great idea. It's been very powerful. It's served us well. There are some caveats, some difficulties with this approach. Step 3 here, when you glue problems together, they better fit together, right? So you need to have well-specified interfaces. So here we have one thing, here we have another thing. Okay, do they work? Yes, they do, right? Because there is a well-specified interface here, right? In this case, it's a mechanical interface or a mechanical electrical interface, but this interface could be a software interface or some other type of specifying how these two things interact with each other. Okay, so often the problem with this approach is to specify the interfaces in a clear and unique way. Okay, so once you get these two things together, you can actually glue them together. yeah, I mean, most likely they never fit the first time, right? So you have to go back and re-engineer something, and then it works at the end. Okay. Another caveat is that the overall solution is typically not optimal, right? If one would have designed this from scratch and had a complete view of the problem and really spent time on it, we could do something which is more efficient. So the internet we have today is clearly not optimized to its fullest potential, right? So we have to pay something to use this divide and conquer technique. So typically we pay with suboptimality. Anyways, the price of having not optimal efficiency, the gain is that we have something called modularity and flexibility. And modularity means essentially like this. Somebody can engineer this cable and change it and plug it into a switch, and it will still work. You don't have to redesign the switch just because you redesigned the cable. And it's possible because we have defined the interface here. And the same thing is we can update the software hardware in the switch without changing the cable. So this is modularity. It's very, very powerful, right? And then also flexibility in that you can re-engineer parts of the system without affecting the overall function of the system is very, very powerful. Okay, so this is the paradigm that's driving the communication networks today, to divide and conquer, re-engineer smaller pieces, glue them together with well-defined interfaces. Okay? All right. So these small pieces, when it comes to one way of looking at communication networks is to look at the overall problem in terms of layers. Okay? So this is a fundamental concept in communication networks that's proven to be very, very powerful. Okay. So what is a layer? Okay. So before saying exactly what a layer is, let's talk a little bit about them. So layers are put on top of each other. So here, to the right-hand side here, we have what's known as a protocol stack, where layers are put on top of each other. And the bottom layer is called number 1, and the top layer is whatever, depending on how many layers we have. It could be 7 or 4 or 5 or something like this. Okay? So we have a number of layers on top of each other, and they have numbers. And the purpose of a layer, and this is a crucial thing to pick up now. So a layer has one purpose, and that is to provide a service to the layer above it. Okay? And to provide this service, it does that by using the service of the layer below it. Okay? So layer 3 here provides a service to the layer above it, to layer 4. And it does that by using the service which is provided by layer 2, which is provided to layer 2 by using the services of layer 1. Okay? So services is something which is provided up into the protocol stack. Okay? And to provide this service, the functionality of this service, layer 3 is using the services of layer 2. Okay. And we will see many, many examples of this, okay? But this is the idea, that the protocol layers are providing services up by using services that's provided to them from below. Okay. Now, another thing is that each layer here is operated according to certain rules, which are captured in something called a protocol. So a protocol is a set of rules for how two or more communicating entities in a layer interact. And this will be clearer in a few pictures. So if you think this is confusing now, that's okay. It will be clear a little bit later on. Okay, and a set of layers with protocols is called the protocol stack. Okay, so before we proceed here, any questions on this at this moment? No, okay. So let's go on and do an example of this before going into the more formal things here. So we all know web browsing, right? So what is this? Well, the web itself, it's a structure where we have it consists of HTML documents, hypertext markup language documents, and other resources, videos, pictures, you know, you name it, right? Which are located on servers, some piece of hardware which stores this information, and they are connected to the internet. Okay, so that's the web, right? So a web browser, Chrome, Firefox, Edge, whatever your Opera, whatever your favorite browser is used then to locate and display these documents to the users, video or text or whatever it could be. Okay. Now a resource, is specified by these URLs, Uniform Resource Locator. Okay, and you've seen these types of links before. So let's dissect what does that link really tell us. Well, the first thing it tells us is the protocol which is used here. So HTTP stands for Hypertext Transfer or Transport, I don't know. T for something, transport or P. We will see later on what it means, I forgot. Okay, protocol. So this tells us that to access this resource we use this protocol. And then there is a host specifying which machine on the internet is storing this information. And then there is a path to that resource, a file descriptor essentially. Okay, so when a user clicks on a link with this URL or types it into the address field of the browser does the following things, the browser software. It finds the IP address to the host, or this edge device, and then connects to it, and then requests the file from the host, and then display the result. Okay. So let's go into the first step. Find the IP address. Okay, because you can type in the IP address in your address field of your Internet Explorer, Edge, or whatever. But this is tedious, right? Who remembers the digits that identifies the Chalmers web server, for instance? So we typically use these internet names instead. Okay, www.chalmers.se. So this is the internet name of the host, and it's really useful for humans, right? It's very descriptive. We can figure out, okay, so it seems to be a web server, and it belongs to Chalmers, which is located somewhere in Sweden. Okay, it's very useful for us. So to connect to the server, the browser needs the IP, the internet address, or the IP address of this one, okay, because that is needed for the internal working of the network. So the browser uses a protocol called Domain Name Service, or it's the system, Domain Name Service, or DNS, protocol to look up the IP address of this one. Okay, so we have the web browser here, and the user at the web browser clicks on or requests some information from this host. So the first thing the web server does is to ask its DNS server, a Q here stands for query, and it basically sends a message to it and say, okay, so could you please give me the IP address of this host? And the DNS server looks this up and then answers, DNS answer, and it says 129.16.71.21. Okay, so now the web browser, or the host here, the host which is running the web browser, knows that www.chalmers.se has IP address 129.16.71.21. Okay, good. Step 1 is clear now. Step 2 is to connect to the server. Okay, so the browser opens up a connection to the server using a protocol called TCP. Okay, so it stands for Transmission Control Protocol. Applications are addressed using port numbers. So we know that the web server software always listens to port 80. Okay. So we know that the web browser here, or the web server software, is running on top of a protocol stack, and to reach that web server, we need to address that through port 80. Okay? Some other software is running over port 25, some other is running over port 35 and so forth. The mail server, the DNS server, whatever, right? But if we want to reach the web server software at this host, we need to address that by port 80. The web browser software also needs a port, and it uses a temporary one because it's something that it uses until it is under execution. And this is called an informal or temporary port number. Okay, so what happens now? Well, the web browser wants to connect to the web server. So it sends a TCP connection request from this IP address. I just made up an IP address of the web browser host. And it has some port number. And this port number here is something which is randomized. It's different from each time you fire up your web browser. Sometimes it changes also when during its lifetime. So this is the informal port number. The web browser software here is running over port 80. Okay, so we know that from the beginning. It's just well known that this is the case. Okay, so the next thing that happens is that hopefully the TCP in this computer here says, okay, it's okay to connect to me. Okay, so now we have established a connection between the web browser software and the web server software. Okay, and now we can start to request information from this web server. So this, okay, and by the way, this TCP interaction is quite simplified now. Just to, it's many things that happens here that we haven't talked about. Okay, so the next thing to do is to request a file. Okay, and the web browser requests the file from the server using a protocol called HTTP. So there is a language associated with this, a syntax and so forth. Again, applications are addressed using port numbers. We know that the web browser is listening to port 80 and the web browser uses this temporary port number. Okay, so remember now that we have established the TCP connections. We have now a connection between these pieces of software, the browser and the server. And the browser asks the server, get, which means, please give me this file, okay, using this protocol, okay? Because there are different versions of HTTP, and the web server needs to know which dialect of this protocol the web browser is using. So it's using 1.1 in this case. There's 1.0 and 2.0, for instance. There might be 3.0 sometime. Who knows? Okay, and then it specifies also the host here. This is the web server that we're looking for, www.chalmers.se at port 80. And the reason for this is that this machine actually could run several web servers at the same time. It's typical that if you have a small web server, for instance, that you ask somebody to host this for you. So a machine here can host, 6 or 7 different web servers. So we need to specify this in order for this one to figure out which one we are looking for. Okay, so once this is done and if everything is okay, we get an answer. It says HTTP 1.1, 200 means okay. So we found the file and then the file follows. Okay, if this file does not exist, you get an error message, typically 400 or something like that. You've seen that also sometimes when you type in, you get, something went wrong, error code 400. Okay. And again, this HTTP interaction is simplified. And okay. So once the web browser has found gotten this code, the HTML code, it parses it and displays it to the user. Okay. Questions? Okay, what's fun about computer networks is that we can actually very easily do some experiments on top of that. So let's see if we can actually mimic what we have done here. see if this works. Okay. Oh. So I have a Mac, but you can use a terminal on your PC or whatever. And so let's assume that we are now a web browser, and I'm the web browser, and my user has clicked or requested the page from the home page of Chalmers. Okay, so I know my user would like to talk to www.chalmers.sc, but I have no idea what the IP address of it is. So the first thing I do is I ask for the IP address, and there is a software here called DIG, which is a user interface to DNS protocol. There is also NSLOOKUP if you're familiar with this. So then I ask for this address. Okay. So please give me the IP address of this. So I send this off, and it goes to a. Okay. So I do this again. Let's see now. So what happens now is that I connected now to, my laptop computer here connected to a DNS server, and the DNS server said, okay, you asked for www.chalmers. The IP address is 129.16.71.10. And this is the IP address today, right now. It could change for tomorrow, who knows, right? We don't know. It's dynamic. Okay, but now I know it's 129.16.71.10. Okay, so the next thing to do is then to connect to this, and I use TCP to do that, and there is a software called Telnet that's a user interface to TCP, and a few other things here. Okay, so then I need to know the syntax of this. Okay, so it's I wanted to connect to 129.16.71.10. Okay. Okay. So this is the IP address of the machine I would like to establish a TCP connection to, and I also would like the TCP connection to be associated with port 80 because I know that the web server software is running there. Okay. So let's see if this works. So it's connected now. It tried, it went very quickly, so now it's connected. So now I'm talking to the Chalmers web server here. So now TCP connection has been established, and now I can start to talk HTTP with the web server, because the web server understands HTTP here. So now I can get a resource from the web server. Okay, so which resource do I need to do? Well, that depends on what the user asked me to do, but it wanted the home page here. So it's .en pages default.aspx. Yeah, I think that's it. Okay, so this is the resource I would like to do, and I also need to tell the web server that I understand HTTP 1.1. Okay. I also need to tell the web server which host I'm looking for. That is what web server I would like to talk to. So the host here is www.chalmers.se, and actually I would like to speak to port 80 on this one. Okay. Now when I hit return, hopefully I will get Chalmers web page back if I typed in everything correctly. Otherwise I will get an error message. Let's see. Oh no. Yeah, here it is. Okay. So here's Chalmers web front page. It's quite large actually. So let's go up and see the start of it. Oh man. That's why it loads so slowly. There's a picture of some sort. Yeah, okay. So remember that I just typed these things, right, with a single new line after that. So this is the answer we get from the web server. It says, okay, there is such a file, and there is some information about that file, blah, blah, blah. Date, for instance, when it was last changed, and then the content length here. So today, Chalmers' homepage, or just a few seconds ago, it consisted of 95,341 bytes. Okay, and here it is. So the next step to do now is, for me, if I was the web browser software, is that I would parse this and then display it for the user. So this is it's pretty cool that you can do this without any special hardware software. You just need a terminal, and you can go about doing things like this. Okay, so back to this. Now we've seen an example of these protocols, how they interact, and how one can establish connection over a network without knowing very much. Because I didn't know the IP address, for instance, of the web server when I started. But I used a protocol DNS to help me figure that one out. Okay, so there are a bunch of these helper protocols to just look up services for this and that. So in this web browsing example, we encountered several protocols. One is this hypertext transfer protocol. It's not transport, transfer protocol. Basically tells you the syntax of get and the error messages, what it means and so forth, and also some logic in what you should do when you get requests. DNS is another one that also specifies how do we ask for an IP address and how is the answer formatted. And then we had TCP, which is the connection protocol that connects actually my laptop with the computer which hosts the web browser, server. Okay, so the question is, how are these then related to layers and services? Because that's what we said. Protocols lives in layers and they provide services. So again, a protocol, what is it? It's a set of rules that determines how two or more communicating entities in the same layer interacts. Okay. So messages are sent and received between these communicating entities, and actions are then based on events, for instance, sending and receiving messages, but there could also be other things, that expiration of timers and other events. User interactions, for instance, could also trigger something to happen in the protocols. So if we look at one example here, so to the left we have node A, so it's a computer that is hosting a protocol stack, that's running a protocol stack, and on the other side here we have a node B, which is some other piece of hardware, which is running a protocol stack. And if we looked at the nth layer of this, so layer n, could be 1, 2, 3 or whatever, it's connected then to something in layer n here. And we have pieces of software running inside this layer. So we have protocol A running here, and a instance of running this is called an entity. So here we have a process, a computer process running in this computer, and it's executing protocol A. And this entity here communicates with the entity at the other side. So this is the protocol A entity at the same layer, but at some other computer. And they exchange messages here, back and forth, back and forth, back and forth, according to some protocol. So protocol A. So this could be HTTP or could be TCP or whatever, right? In the same layer, there might be another protocol which is running simultaneously, perhaps, and it's communicating. This software process is running, and this is running, and they are exchanging messages back and forth also, according to the protocol B rules, and that could be DNS, for instance. Okay. So the purpose then of a protocol, as we said earlier, is to provide a service to the layer above. And and so it provides a service up here by exchanging information with its peer, its jämlike, its buddy, which is speaking the same language at the other side. Okay, and together these entities then provide a service which goes up in the protocol stack. So, for instance, DNS provides a service up here, and the service is basically to, you know, translate between IP addresses and internet names.
And there's nothing special about A and B in this example. It's just you choose.
Yeah, A and B could be anything here, right? But the main point here is that protocols speaks with protocols on the same layer. So it doesn't. This A here does not speak with something above or below layer N at the other side. So communication goes horizontally here. Okay, so both HTTP and DNS are application layer protocols. So they are in a layer called the application layer. So that means that HTTP and DNS provide communication services to application programs. Okay, so the application layer does not run application software. It provides services for the application software. And application software, what could that be? Web browser, email clients, and so forth, right? So web browsers is using HTTP and DNS to do its job, right? So these are services to the software. So HTTP and DNS use the transport layer service, which is the layer below the application layer, to provide the services. Okay, so let's see an example here. So remember that we had web browsing software here, and we have web server software. So the web browser here would like to request some information here. So how does it do it? Well, it makes an HTTP request. So it asks the application layer to send an HTTP request over to the web server software, which answers through HTTP like this. So data goes like this, back and forth, right? And the interaction between these two nodes here is according to HTTP. Okay, so the language which is spoken here is HTTP. Okay, now, of course, we know that data is not directly, magically going from here to here. So this is only the virtual path of the data. The physical path of the data is down in the protocol stack, right? Because the HTTP is using TCP to do its job, right? So HTTP is unable to connect here by itself, but it uses TCP to do that. So HTTP here asks, oh, TCP, can you help me out here? I'd like to connect to this IP address, to port 80. And TCP say, okay, I can try, and it does it. And then data is actually going this way, right? Down from the web browser software, HTTP over a TCP connection, up through the TCP connection to HTTP to the web server, and down like this. Okay, and the interaction between TCP layers here, the TCP entities here, is according to TCP messages. Okay, so TCP is talking TCP, HTTP is talking HTTP, right? But TCP is helping HTTP to provide the service to the web browser. Okay. Okay, so how does TCP do its job, right? Come on, 1, 2, 3. Well, this is also virtual communication. Okay, so TCP is using the services or layer below it, and we will talk more about that later on. And it would do that down, down, down until we get to the physical layer where information is actually going over a cable or something. Okay, so let's finish with this to see whether we have gained understanding today. So I'd like you to answer this quiz. It would not be graded, but just to figure out if we are on the same page here. So what is true here? We have three statements. So the first statement is that the layer can contain many protocols, or a protocol can span many layers, or there is exactly one protocol in each layer. Okay. So how many things one? 2? 3? Okay. So actually, the correct answer is number 1. So the application layer could contain many application protocols. Transport layer can contain many transport protocols. But a protocol belongs to a layer, right? So a protocol should not be both in the application layer and the transport layer at the same time. It's either or, right? So, second question here. What is true by an application program, for instance, a web browser? It is a protocol in the application layer. It uses the services of the application layer, or it provides services to the application layer. So how many things? 1? 2? And 3? Yeah. The correct answer is 2. So the application software resides on top of the application layer, which means that it uses the services of the application layer. The application software is not placed in the application layer. Okay, that's a common misunderstanding. So that's why I had this question. Okay. Okay. Then the application layer protocols is using services of the transport layer, which is below it, which is using services of the layer below it. Okay. We'll reiterate this as we go along, of course. And the last question here. So what is the main purpose of a layer? To provide services for the layer below it, to interact with the corresponding layer at some other computer, or to provide services for the layer above it. Okay, who thinks number 1? Number 2? Or number 3? Very good, okay. So here, number 2 is correct, but it's not the purpose, right? It's just the means. The purpose of the layer is to provide services, and it does that by interacting, okay? So here you have a little bit of a flavor for what a quiz could be. When it's the quiz time on Monday, I believe. Monday is the first quiz. Then you will have statements like this. Some statements might be true, but they're not super true. It's not the ultimate answer to the question. So I know, I'm happy that have a driver's license which is very old, but if you know the driver's license test, these are also like this. Many things are true, but there is one which is mostly true. Okay. All right, so let's take 15 minutes.